Have you ever, paused to think about what's going on behind the scenes when you connect to Wi-Fi? At work or maybe even trying to get online at a packed stadium. It just sort of works, right?
Right.
But there's actually a ton of clever stuff making it happen.
Exactly. And today, we're going to dig into that. We're looking at the actual technical guides, the blueprints for wireless access controllers, ACs, and the access points, the APs you see on the ceiling. Our mission really is to sort of pull back the curtain on the configurations that power your connection every day, give you a bit of a shortcut to understanding it all.
Okay, let's unpack this then. When you connect at the office, that connection feels, well, secure, right? It's not just wide open. How does that digital handshake keep things safe?
Right. So what's really key there is something called 802.1x authentication. Think of it like a really strict ID check for a private club. You need your specific username and password, and those get checked by a central bouncer, technically a radius server, maybe at an address like 10.23.103.1 on port 1812.
Okay, a central checker.
Yeah. And the big advantage for you is your connection stays solid. Your services don't drop, even if you walk down the hall. It keeps track of you. And technically speaking, this setup usually uses what's called direct forwarding for your data, often with separate virtual networks, VLANs, keeping management traffic away from your work stuff. VLAN 100 for one, 101 for the other, keeps it organized and secure.
That makes total sense for employees. But, okay, what about guests? Like you go to a hotel or a coffee shop and you get that pop-up page you have to click through. How's that set up differently?
Yeah, good question. That's generally a completely different beast. For guests, you often see something called MAC address prioritized portal authentication. So when you first try to connect, boom, you're sent to a specific web page, that portal, before you get real internet access.
Yeah.
Sometimes it uses a server like 10.23.103.1 on port 5200.
Right, the login page.
Exactly. And here's a significant difference. The data flow. Instead of direct forwarding like staff get, guest data often uses tunnel forwarding. Imagine your data gets put into this special pipe that routes it back through the main controller first.
Okay, so it's less direct.
Yeah, it gives the network admins more control over guest traffic, which makes sense for temporary users, right? They can manage who's on for how long. They might even set a 60-minute timer on your device's MSE address, so if you disconnect and reconnect quickly, you don't have to log in all over again immediately. Pretty handy.
Okay, here's where I think it gets really wild. Picture that stadium again. Thousands, maybe tens of thousands of people all hitting the Wi-Fi at once. How on earth do they stop it from just collapsing?
Oh yeah, stadium Wi-Fi. That takes what's called a high-density WLAN configuration. It's basically a masterclass in network tweaking. The guides talk about all sorts of strategies, like band steering pushing devices that can use the faster 5 gigahertz frequency over to that lane, away from the crowded 2.4 gigahertz.
Like traffic management for radio waves.
Sort of, yeah. And they'll increase the number of users allowed per network name, per SSAD, maybe up to 128 or even more. Then there's user isolation. This stops devices from basically shouting at each other across the network with unnecessary background chatter like ARP packets. Kind of puts everyone in their own little bubble.
Keeps things calmer.
Exactly. Plus, they fine-tune everything. The timing of beacon signals, maybe setting intervals to 160 milliseconds, and meticulously planning AP channels and power levels to minimize interference. It's all about giving everyone a fair shot at getting online.
Okay, one more scenario. What if you need Wi-Fi somewhere tricky, like extending it across a campus green or into an old building where running new network cables is just a nightmare or super expensive?
Right, you can always pull fiber everywhere. That's where WLAN backhaul using a wireless distribution system, or WDS, comes in. It shows how flexible this can be. Essentially, some access points, instead of being wired back to the network, talk wirelessly to other APs.
Ah, so they relay the signal.
Precisely. They form a chain, like passing the signal hand to hand, often using that robust 5 gigahertz radio band for the link between them. It's a really smart way to push coverage out where wires are impractical, making sure even people in those harder-to-reach spots can still get on the enterprise WLAN.
So when you zoom out, it's pretty amazing. From that secure login at work to handling huge crowds, even stretching Wi-Fi reach without wires. There's this whole hidden layer of planning, making your connection just work.
Absolutely. So the next time you connect, maybe just take a second. Think about all those invisible, carefully planned configurations humming away behind the scenes. Makes you wonder, right, what other technologies we use every single day have these incredibly detailed hidden manuals ensuring they work, but we just, take them for granted.
Yeah.